Okay, let's go. This is IT Unit 2, 2024. Let's start. Module 1, supposed to be information management, usually database stuff. Good stuff about databases and collecting information, SQL, normalization, all of that stuff. Question 1, Pagira ordered an item from an overseas company via its website. She purchased the item and received a tracking number. To monitor its delivery status, Pagira checked the tracking information regularly and received notifications via email and text messages until the package arrived at her doorstep. There are 2 ways in which the evolution of the internet has improved computer service. So the internet, I think you're supposed to teach this in module 2. This is part of the syllabus. Although it's a kind of straightforward question, but common sense is not always helpful. How has the internet improved customer service? So state 2 ways. She purchased the item, receive a tracking number, monitor its delivery status, and receive your information via email and text message. Okay. One thing that it has improved is real-time updates. Real-time updates on the status of packages. And next Amazon placing orders at 24/7 via websites. 4 lines is a lot for a state question because state is only the state where you ever have to state. You have no explanation to do. There's no explain part of it. So yeah, that's about it. If you use up the 4 lines, that's nice for you. Those are my dogs, by the way, barking at 5 a.m. in the morning when I'm doing this paper. You think they'd be quiet right now, huh? You think so? Alright, figure 1 below is a report which shows the tracking details for the ordered item. Alright, this is the item. Accepted and transferred out for delivered. It looks kind of, it has a kind of Amazon feel to it, as a kind. Figure is dissatisfied with the time between order and receiving the item. Using an example from the report, determine whether there is enough information to support her claim. Okay, so ordering and receiving the item. Oh, they drag USPS under the bus there, boy. Yes, there is a claim here because November 24th to December 5th is a lot of time before it passed through the facility. So say yes, there is enough information. Yes, there is enough because the initial purchase date, no. Just now, I'm gonna wait for my dog to stop barking. Put the stuff now. Okay. So yes, there's enough information because the time between the post office and processing is almost 24 to 25, 4, 5, 6, 7, 8, 30th, 31st. It's more than 10 days. More than 10 days. This information can build a solid deduction. Yeah. Okay. So information processing always have to make you gather the information and build some sort of deduction out of it or some sort of findings. So the findings that you got is 10 days, right? So 3 marks, 1 mark for saying yes, and next mark for showing how you got it, and a 3rd mark for tying the theory back into it. Because remember, you always have to tie the theory back into the answer. Because it's not just common sense, you actually need to know some of the theory to be able to give them it in the answer, because most likely that's what the answer sheet is going to have, right? A customs broker wants to determine the number of locations at which the item was scanned using a suitable field names. Write an SQL statement to count the number of locations. Ooh, okay. Suitable field names. What we're gonna do? We just had to create field names. Oh, that's weird. Alright, select locations from, I don't know, from the orders table. Yeah. I mean, they didn't really give you a table to work with, so you just had to kind of make this up. Where, I mean, it's definitely a query, so you had to use select from where. I did not know count was on the syllabus. Yeah, I don't think it have count stated anywhere on the I'll have to double check the syllabus and see if they actually have count, but I think for the count, you have to put select, then put the word count, the thing that you want. So select locations as something, and you gotta give it a name. I think as total locations. Yeah, I didn't know that this was on the syllabus, where our customers will also determine the number of locations in which the item was scanned, where what scan equals true. Yeah, this question, I don't know how this, I'm not too sure. Count locations. No, you can't put count locations there. They wanted to count the number of locations. So every location. Okay, so every location. So count everything where item was scanned. Okay, so you put asterisk here because you'll count everything, and you create a variable, a column called total locations from the orders table where scan is equal to true. Yeah, I cannot tell you that I knew count was on the syllabus. I don't think I've ever taught count to a student. These are the things that make teachers kind of like be like, oh, they can ask that now. Yeah. So for the students who probably did this exam, they had to wing it. I don't know if anybody that gets correct. Or probably the teachers that knew you have to teach count, but honestly, I didn't know you had to teach count. Well, I hope you all made it through that. The company has received complaints from other customers regarding delays in the delivery of their packages. The complaints database consists of the following customer and location tables. Using the tables and the complaints database, identify the foreign key and the table. Okay, so the customer ID. Okay, location ID is the primary key here, and the foreign key here will be location ID. So, the table which the key is found. Okay, so foreign key is location ID in the customer table. I think I'm correct there. Yeah. Yeah, the foreign key is location ID in the customer table. That's all they wanted, 2 marks. Yeah, because this one will be the primary key, and the primary key here will link to the foreign key here, so you could look for a location ID. Yeah, even though the referential integrity no one but explain the relationship between the customer table and the location table. The location table is in a one-to-many relationship with the customer table. But they ask for customer to location. Okay, customer is in a one-to-many relationship with the location table. Yeah, that seems right. Write all the relevant information which relates to complaints from customers at location 345. Okay, location 345. Write all the complaints, that's what I said? Or write all the relevant information which relates to complaints from customers. Okay. Alright, so what relates to our complaint? 345, we have the location, we have the customer name, and we have the ID. Okay. Snug Sand. Okay, location Snug Sand. Snug Sand is in it? Alright. Snug Sand, name Vanessa, and customer ID 4. Name Vanessa, customer ID 4. Snug Sand. Yes. Vanessa. 1 day delivery. Yes. Okay, out of any 1 day delivery. 1 day delivery. Yeah, that's right. Everything that relates back. So anything that has 345 minutes, I just pull this information, location name, 1 day delivery, yes, and then check the relationship up here, which is the same 345, and link it back, and then link it back. That's basically what the database will do in the query. That's how queries work in a database. Yeah, let me just let you know that SQL in Unit 2 is a thing, and the SQL in Unit 2 could get a little complicated, but I didn't know you had to do count, so I'm adding this into my teaching this year. So really the coolest thing about these past videos is that I get to explain while doing a question. So a lot of you would learn things that you never saw before just by me working on the question. But sometimes I can't explain every single thing, and I don't know, you might need help explaining. So 3088799, WhatsApp that, and find out what we have available. It might be a crash course, it might be a class. Remember, when you join my classes, all of the classes are recorded, so you'll get to see every single thing that we did from the start of the syllabus. So If you're not sure about certain questions and you're not sure because the explanations I give in the past papers are a little too fast, then WhatsApp the number. See what we can do for you. If not, hope you enjoy the videos and hope you learn a lot while you go through these past paper answers, right? Cool. Alright, outline the purpose of normalization. Alright, normalization has a lot of things, but normalization is to reduce inconsistencies in a database, making it easier to find and update information by addressing insertion, deletion, and update anomalies. Yeah. Once I mention insertion, deletion, update anomalies, and reducing inconsistencies, yeah, good. Oh no, they asked for that in the next part. State two anomalies other than insertion anomaly. Okay, maybe I shouldn't have put that in any explanation. What else they want? Reduce the inconsistency in the database, make it easier to find and update information. I think that's a good one, but I just added in the anomaly stuff because I thought that's what they would need. And clearly they want that in the other one. So update and deletion. Those are the three anomalies that in normalization trying its best to figure out to make it easy for you. Alright, a sample of data for a ticket order by customers to a number of events is captured in the table below. Cool. So you have a table here. Everything in the table seems to be atomic. Atomic means that there's only one value inside of a field. Yeah. Alright, John Chen wants to change his ticket order from the comedy show to the music fest. However, the quantity of his order remains the same. Other than event name, identify two other fields that would be updated. Okay, John Chen. Who's John Chen? John Chen is this guy here. John Chen wants to change the order from comedy show to music fest. So if you change it to music fest, you'll have to change the date because the date will have to get updated. The type, well, it could be general admission still, but he didn't say that the type. Quantity not gonna change, the price will change because the music fest price is 200. Alright, so event date and then event price, total price. Those will get updated. Yeah. I'll explain how the rules for first normal form can be applied to the table. We could move repeated data so you could get the customer name, and then you could have a customer table and you could have a order table. Yeah, okay. So you can have a customer table. The repeated groups can be broken up. Customers and broken up in customers table and event table. I mean, technically a customer could go to two shows, right? Yeah, so you could have customers in a separate place and then you could have the events in a separate place also. And then probably have an order ID table or orders table. But 2 marks, they basically wanted to show that you could set up two things. Separate customers from the events and your life will be a lot easier. Alright, you're in developing a ticketing application. I'll keep track of the number of tickets sold, events for which the tickets are sold, or persons purchasing tickets. Once it's 72 hours before an event, a person can reserve a ticket for 24 hours, after which that ticket is no longer available for purchase. If the ticket is not purchased within 24 hours, then it goes back into the pool of available tickets. Otherwise, it's removed from the pool of available tickets. Show an entity relationship diagram for the ticketing application that can be implemented. Alright. There's a big ER diagram though. I don't remember them being this big. Okay, let's try. So customer is an entity. Can reserve all this stuff about 72 hours before and 24 hours before. All that stuff is flop to me. I guess maybe if we go through it, I'll always see. So one customer can reserve how many tickets? Once it's 70 hours before an event, and a person will reserve a ticket for 24 hours after which, okay, so one customer can reserve one ticket. Primary key will be the ID, and the ticket would have the customer ID. So the primary key, well, I'll double underline the primary key, and the foreign key, I'll single underline it. What is happening here? Right, so a customer could reserve a ticket But how the 72 hours coming into it and the 24 hours coming into it? So the ticket is not purchased within 24 hours and it goes back into the pool of available tickets. Otherwise, it's removed from the pool of available tickets. Is the ticket okay? This ER diagram is confusing me. All right, so let's create something called available tickets. So one customer could reserve one available ticket. Let's just leave that, right? An available ticket can be placed in a purchase ticket. No. Yeah, right. Okay, so available ticket can be placed in a reserve ticket. So one available ticket can be placed. You could have one available ticket placed in, it had to be 1-to-1. And then if the ticket is not purchased within 24 hours, it goes back into the pool of available tickets. So then one customer now could purchase the reserved ticket. Let's look at that there now. It's deeper making sense. Everything is 1-to-1 here, just not adding up, but I think that looks like it. Now the primary key here, a reserved ticket will have this will have an ID, like a ticket ID, and then this will also have ID here, because both the tickets will have the same ID numbers. So a ticket could be an available ticket or a reserved ticket, and a customer could have a reserved ID, that's a primary key, and then a purchase ID, which will be the foreign key here for that table. Yeah. Okay, let me see if my logic making sense. Is it possible for a customer who has an ID to reserve an available ticket and their customer ID be put in the, I'll put the customer ID over here too, CID. Yeah, I'll put the customer ID on the reserve ticket, right? So one customer could reserve one available ticket. The ID here will relate to the customer ID over there. And then that available ticket can be placed in the reserve ticket table, which will put the ID of that ticket inside there. And a particular customer ID could purchase that reserve ticket once it's there. Yeah, okay. Yeah, this question is a tough one. This one, yeah.
That's all I needed. That's all I needed for him to do that. And it became personal with me.
Yeah, I wasn't feeling too happy about this question, but okay, we made it here. If you have this question is hotly debatable. I would love to hear some of the other answers that people have for this. So you can let me know in the comments what some of the other answers that you think may be viable for this. I'll probably have to run this through some other teachers. But as far as I could see, this goes through the logic here. The only thing I'm not too sure about is how many tickets a person could buy, but they say a person can reserve a ticket. So I don't think there's many inside of this one. But yeah, this one quite debatable, but ambiguous as always. So let's go. Right, good. Made it to the end of module 1. Now let's go on to module 2.